You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
And our lines are open for you. Chris is here to take all your questions on 021 446 0567 011 883 0702. And we are taking your SMSs as well. So join our conversation. Chris, good morning.
Good morning.
Thank you so much. We're always fascinated by this. When there is a discovery, the oldest remains have yet discovered of the ancestors. Tell us about that.
Well, scientists working up in Ethiopia, the Afar region of Ethiopia in the Great Rift Valley there, have uncovered what they say is the earliest remains yet uncovered of our own genus, Homo. In other words, the ancestors that ultimately led to us being here. The earliest remains of Homo discovered before this present specimen date back some 2.4 million years-ish. This specimen, which comprises a lower part of the jaw with some teeth in place, and they're clearly Homo teeth, that was found in a part of the sedimentary progression which dates back, based on dating relevant or relative to various sediments and layers of ash from nearby volcanic eruptions, to up to 2.8 million. So it pushes back the origin of our immediate ancestors by about another 500,000 years or so, putting us on the planet 500,000 years before paleoanthropologists thought we had previously popped up. And intriguingly, this study, which is published this week in Science by Bill Kimball and his colleagues at the University of Arizona, this actually ties in the appearance of Homo more closely with changes to the weather and climate patterns that were happening in Africa at around the same time, with Africa opening up, becoming much drier and more seasonal. There was a greater seasonal variation between winter and summer than there had been previously, and this presumably created the evolutionary niche, the opportunity, the habitat into which Homo then steps. In other words, it was the selective pressure that drove the evolution of the genus that was ultimately to lead to us.
Righto, so there we have it. Thank you very, very much for... Now, when something like this happens, Chris, because I imagine that research happens across different universities, the discoveries happen at different parts of the world. Do the different research institutions, academic institutions, share the information? How does it impact, how does one finding or discovery impact on the work done by another, for example?
Well, everyone around the world is continuously looking at what everyone else is doing, because the whole process of science is that science is a big debate, and scientists have not answers, but they have solutions to hypotheses. And when you ask a question in science, you get an answer to your question, which enables you to then ask another question. And so scientists are continuously looking at the answers that each other produces and then testing those questions in new ways, in other words, to try and reproduce that data and fill in gaps. So science is a moving front, which is a shared experience, but everyone has their own perspectives and their own theories, and eventually that homes in on one particular suggested theory to explain things. This part of human evolution is a very packed landscape. There's a lot at stake. There's a lot of people who've put their reputations on the line to have their own theories about things, and so as a result it tends to actually get quite heated. And because these specimens are rare, there are not many of them, and they don't pop up very often, this means that the landscape, the fossil landscape, is quite fragmented at the moment. There are quite big gaps, and our understanding is based on a lot of conjecture, and it's very important that everyone works together to share their data. And one thing that's actually been pioneered by researchers at Witwatersrand University, Lee Berger, who I've met on a number of occasions,
yes.
The effort done there is to try to encourage more collaboration and open sourcing of data, projects to try to bring scientists from many institutions around the world to work on things, but also then encourage them to then publish that and put that data into the public domain so everyone has access to it. And this is the way that's going to change the way we do science in this domain.
Thank you very much. Shall we go to Patrick in Khayelitsha? Good morning to you, Patrick.
Good morning, Rudy. Good morning, Naked Scientist.
Carry on, please.
I'd like the Naked Scientist to help me here. Chris, do you remember in 1990s there was an outbreak of a strange phenomenon of disease in England called the BSE?
Yes, I remember this very well. Yeah. That's right. It was
the bovine sponge. The bovine spongiform encephalopathy, mad cow disease.
Right.
Yeah.
And my suspicion was that it is because people wanted to increase milk products, and then they feed animals with meat meat like bone meals and fish meals, all kind of things. Do you think it is all right for us to do that, to give animals meat, animals which are not supposed to be eating meat by nature, like for example carnivores, herbivores, that kind of stuff? Do you think it is good for us to do that, or did that have an impact? Am I right to make such a conclusion?
Hello, Patrick, and your recall is excellent and you're spot on. No, it's not all right to feed meat of an animal back to itself, and this is exactly what happened. In order to boost milk yield, you need to put lots of protein into your cows, because at the end of the day, milk is very rich in protein, so if cows are going to make a lot of good milk, you need them to have enough good protein in their diet. That source of protein would be expensive, so one practice to save money was to take rendered cows that have been slaughtered, and the bits that no one wanted to eat, you grind those up, bone, other bits of sinew and so on, and you feed that material, including bits of brain and nervous material, back to other cows in the form of protein-rich pellets. The process that was used to prepare these protein-rich pellets was to just render and boil up the material at a temperature of 100 degrees or so. This is not high enough to break down an entity that was in the cows called prion proteins. Now, this is a normal protein that's in the brain, but under very rare circumstances, and it happens in humans as well, this protein can change from being a globular structure resembling a ball of wool to becoming a rigid, flat plate-like structure called a prion, a scrapie prion. And the interesting thing about these proteins is that when you introduce this rigid, bent form to the more globular ball of wool form, the rigid form has the ability to convert the ball of wool floppy form into more of the rigid form. And you can see where this is going, because once you've got some of the rigid form and you've converted more of the rigid form, it goes off and gets more of the globular form and turns it into more of the rigid form, so you have a positive feedback loop. And we think that's what happened, that one cow randomly developed the equivalent of BSE. It got into the food chain, it got into other cows through the diet. This then increased in the cow population, the number of cows with the BSE problem. Because cows were looking a bit iffy at times, farmers would say, well, rather than wait for this cow to get really sick and then it's not sellable, I'll send it off to market now and get it off my books. And this put more of the agent into the food chain, and before we knew it, we had an explosive outbreak. Now, the writing was on the wall, because many decades ago, scientists and doctors had seen exactly the same phenomenon happening in humans. There was a group called the Fore people, F-O-R-E, Fore people from Papua New Guinea. They had ritualistic practices which involved eating the dead. And the people who ate the dead were usually females in the tribe. And the females manifested a condition called kuru, which actually translates into he who trembleth terribly. And what was happening in these individuals is that someone had a condition called CJD, Creutzfeldt-Jakob disease, or a disease like that, which is the human equivalent of BSE. Because people were eating the brains of these dead ancestors and relatives, they were bringing those proteins, the scrapie prion, into their body, and it was going into their nervous system and causing the disease in them. And then other people, chiefly the women, were eating these dead people, and this was reinfecting the population. And when doctors saw what was going on and they put a stop to the ritualistic cannibalistic process, at that point the disease fizzled out. So we had all the evidence there already that if you feed an animal to itself, you have a danger of this sort of thing happening. And so we've learned a very hard and very costly, in terms of human costly, because there are still human cases of BSE in humans happening. We're up to a couple of hundred cases now in Britain. So we have to be really careful about how we do this kind of thing, because if you play with nature, you can get your fingers burned.
I'm sure. Shall we go to Joe in Muldersdrift? Good morning.
Yeah, good morning. Must I ask my question?
Yes, carry on, please.
What I'd like to know, good morning to you, what I'd like to know is there are thousands of cars, millions of cars driving on the road all day. Each car has a number of tires on it. Those tires wear down as the cars drive. What happens to the rubber that comes off the tires? Because one would expect the whole surface of the earth would be covered in a thin layer of rubber particles that come off tires. What happens to the rubber that comes off the tires?
Well, Joe, effectively the whole world is covered in a very thin microscopic layer of worn-down tyres. And if you look at the world market for tyres and rubber, it's millions of tonnes every year. Just in America, they're getting through millions of tyres every year, and that's just one country. The whole world is using vulcanised rubber tyres, and those tyres do wear down. Where does the rubber go when it wears down? Well, it goes onto the road surface, because when the wheel is going round, there is friction between the surface of the road and the tyre, and there is also a little bit of slippage. So although your tyre goes round, it slips a little tiny bit as it goes around to accelerate the car, or when you brake and slow down the car, and that gently rubs away the tyre, leaving a thin veneer or film of rubber on the road surface. And this means that when the rain comes, it washes those particles to the side of the road, and the wind comes and it blows the particles off. So that rubber is everywhere. And it's quite a problem, actually, because it's building up. It's building up in drains, it's building up in rivers and the sea, it's building up in us because we breathe the dust in. And in that rubber are other components as well. There are heavy metals, there are other nasties in there, and bits of pollution because the rubber binds hydrocarbons and other pollution off the road. So it's not good. And ultimately, yes, it's going to build up, and if you went and measure everywhere carefully enough, you will find bits of tyre are effectively all over the place.
Okay, Joe. Thank you. I've never actually thought about that before. Thanks for the question. Who came in first? It was Ronnie in Silverton. Hi there, Ronnie.
Yes, hello, morning. I'd like to ask, I've noticed when I've travelled from here to England, I've noticed here when water goes down a drain, it goes in one direction, whether it's clockwise or anti-clockwise, I'm not quite sure. But when you're in England, it goes the other way. Has that got anything to do with gravitational pull on the Earth?
Hi, Ronnie. Well, it of course has to do with gravity, because gravity is pulling everything down towards the centre of the Earth, which is where gravity acts towards. And that's why water goes down the drain at all, because water, being an object that has mass, has gravitational potential energy, and it will go down the drain because it's going from a higher gravitational potential to a lower gravitational potential. The direction it goes down the drain is a very different phenomenon. And I think you're referring to the whole question of, because the Earth is spinning, does this affect the direction in which water going down the drain spins? Now, if you were a Michael Palin Around the World in 80 Days fan, then you'll have seen him get terribly caught out by somebody on the equator in one of his documentary episodes, because they stand where they say the equator, in inverted commas, is, and they say, look, if we stand on this side of the equator, taking a step into the northern hemisphere, the gentleman who's demonstrating says, look, if I put some water in this pot and then I turn to the camera, and you see I subtly said there, turn to the camera, and then I take my finger off the hole in the bottom of this pot, wow, the water goes down and it spins anti-clockwise. Now, if I repeat the experiment and I refill my pot, stand on the other side of this line, south of the equator, and then I turn towards the camera, oh, look, hey presto, the water's going down clockwise, because he's got some matchsticks that bob around in the water and spin. In fact, if you watch what that gentleman did, he's hoodwinking everyone, because when he turns towards the camera in the northern hemisphere, he spins round to the left to show the camera the pot with the water in it. When he's standing on the other side of the line, he spins round towards the right. When he does so, he imparts spin or turn into the water in his pot, which means that it's already turning when he takes his finger off the hole, and this makes the water come out looking like it's spinning. In fact, you can never do this experiment at those sorts of scales. You need to do the experiment really, really carefully, or you need to be a hurricane or a giant cyclone. If you look from space, you'll see weather systems and air systems do spin, but with little pots of water on Earth, the sink in your bathroom or your toilet, this is not going to happen. But two scientists did do the experiment properly in the 1950s. There was a group in Australia, did it in Sydney. I think it's Trefethen et al., and I think it was 1954-ish, and I think they published it in Science, or no, Nature. And another group called Shapiro et al. did this in 1958-ish, I think. Sorry if I got the date slightly off, and I think they published it in the journal Science. It was up in the Northern Hemisphere in America. The way they did their experiment was they had a giant bowl. It was more than a metre across, this bath, and they filled it with water and then left it for a very long time for the water to stop spinning and turning from where they'd put the water in the first place. And then when they opened up a tiny hole in the bottom, right in the dead centre of this bath, over time, slowly, they were able to see the water beginning to turn as it goes down the plug hole. And this is genuinely reflecting the Coriolis effect, the fact that the Earth is spinning, and therefore there is an angular momentum imparted to an object, so it also has an intrinsic spin. But you've got to do the experiment properly in order to demonstrate it. Michael Palin was caught out, and your toilet and your sink are doing it just because the water doesn't come into those objects symmetrically. It actually comes in and it's already spinning.
I have an SMS from Cape Talk. You can quite possibly get cancer from secondary cigarette smoke. What about secondary smoke from candles, fireplaces, or braais? Can that also cause it? It's a question from a listener.
Yep, absolutely. And it's all down to the dose. It's a dose-dependent effect. When you burn something, you are taking complicated molecules and hydrocarbons, and at the temperature of combustion, you rearrange the particles and molecules, and you produce new species of molecules, some of which are things like aromatic hydrocarbons. These are rings of carbon atoms which have the capacity to get inside your cells and then damage your cells and damage your DNA. So they're in any kind of combustion product. The more of that combustion product to which you are exposed, the greater your risk of developing damage to your DNA that could ultimately lead to cancer. So merely cooking food is sufficient, actually, to give you an elevated risk of cancer. But at the same time, being malnourished by not cooking food that's delicious to eat means that you're probably more likely to die. So it's a toss-up, but it's a necessary evil, and you should try to minimise your exposure to any kind of particulates, and especially things like smoke.
Quinton in Pretoria, good morning.
Good morning.
Yes.
What to know is, when you go to a city, in the cities like Johannesburg or Pretoria, those buildings, city buildings, they normally have these pyramid-like objects that are circling around. What is their geographical or their aviation significance if they have?
Chris, did you get that? I didn't understand. Yeah?
I think he's referring to these sort of pyramid-shaped things that spin round on roofs.
Yes.
And I think that the reason that they're put in there is to scare off the birds, actually, in a more aesthetic way. If you have something that's turning and it's got reflective surfaces, birds don't like it because they're always on the lookout for predators. And if they see something that's spinning, it's reflecting a lot of light, and it's something they don't understand, it scares them off. So it basically stops the pigeons pooing all down your building.
Okay, so there we go, Quinton in Pretoria. Wilma in Stellenbosch, hi.
Good morning.
Yes.
I would like to know if it's possible, if I miss something on the radio, why can't I just rewind and listen to your show again?
Well, you can, of course. If you go to nakedscientist.com, you'll find that this programme, we link to the podcast from 702 every week. And if you look up on our website, Ask the Naked Scientist, you will find a link to this programme. You can download it and you can listen to Reedy and me and you chatting all over again. But I think you're actually asking a more subtle science question. Is that right? Which is that basically the radio waves have come from the transmitters in South Africa to your radio. Why can you not go and get them back again? Well, in theory, you sort of can, because radio waves are electromagnetic waves. They are analogous to light, and we know that light carries on going through the ether forever until it interacts with something and hits with something. So out in space, yes, this program will continue to be radiated out into space forever, infinitely, until it hits something. And at the moment, the light from the Earth is in a bubble around the Earth 100 light years in radius, because we've been making radio signals for about 100 years or so. So it's quite awe-inspiring to think this program will carry on into space almost indefinitely, spreading out and becoming quieter and quieter and weaker, but nonetheless there forever.
Thanks, Wilma. I hope they...
well, the problem is that you can't overtake those radio and light waves to go back and look at them, because in order to catch them up and then pass them and then catch them again, you've got to be going faster than the speed of light, which you're not going to be able to do because you can't break the light speed limit.
I've got a question here. With all the fresh water flowing to the ocean, why then is the ocean so salty?
Well, the reason the ocean is salty is that there's a lot of water on Earth, billions of cubic kilometres. Oh, no, sorry, that's wrong. Probably about 3 billion cubic kilometres of water on Earth. And this water, having arrived here in the form of maybe a contribution from comets, but largely a lot of contributions from asteroids bashing into the early Earth, this water was built up and formed an ocean. Energy arrives from the sun, and every square metre of the Earth's surface is hit with energy at the rate of about 1 kilowatt, so that's like a 1-bar electric fire heating it up. This gives energy to the water in the ocean, evaporating it. Because salt particles in the ocean need a lot more energy to boil out of the water than fresh water does, when you heat the water up, the only thing that comes off of a salty water like the ocean is fresh water. So in order to produce fresh water in the atmosphere that's going to become clouds and then make landfall and then drop its rain as fresh water on Earth, you've got to have made the ocean a little bit more salty by the water being taken out of the ocean in the first place. In turn, that fresh water then washes more salts off the land into the sea, making the sea a little bit more salty, but then other chemical processes kick in and remove some of those salts and turn them into insoluble rocks and precipitates and things, so the ocean's level of saltiness is roughly stable, and rivers are only very, very tiny bit salty because of things they leach out of the earth on their way back to the sea.
And then there's an SMS here about the sea. Since we're on the sea, please ask, why is it that when you travel by ship to Mozambique, you don't get seasick, but when you are coming back to Durban from Mozambique, everyone gets seasick? Even on the ship, they put plastic bags all around the ship. They are almost anticipating everyone vomiting. So, Chris, is that it? You can get seasick going one direction, but not the opposite?
Well, I've heard of the band One Direction making people feel sick, but I haven't come across the idea of being seasick going only in one direction. It's sort of feasible in the sense that if the sailings are timed for certain times of the day and those coincide with weather patterns that tend to produce a more rough sailing experience going one way than the other, one could possibly explain it on that basis. But I've not taken the trip myself. Maybe it's something I should do as an experiment. If the people would like to send me some tickets to go and take the trip, then I'll certainly do the experiment and I'll see if I throw up.
Vusi in Sandton, very quickly, we've got 2 minutes.
Hi, Rudy. Love the show, as you know.
Thank you.
Chris, a quick one. In the township where I'm from, when you have dogs, which nobody owns, and there's a lot of them, so they're kind of a community unto themselves, you take 2-liter Coca-Cola bottles and you put water in them. You put it in your garden, and the idea is that it sends the dogs away so they don't poop in your garden. Is there any scientific evidence to suggest that that's true? If there is, what is it? Just curious.
Thanks, Vusi.
I hadn't come across any evidence. I would think that putting water in your garden would be more likely to attract the dogs because they'll come along and have a drink. So, no, I wouldn't have thought so. There's not really a good way to stop dogs pooing in your garden apart from shooing them away.
So there's your answer, Vusi.
Well, you could do it.
I don't believe it.
And then they might think twice about coming to your garden next time.
Yeah, it's quite those 5-liter or 2-liter bottles are quite ubiquitous in a lot of gardens. You fill them up with water and you place them in different parts of your garden, and you think the dogs won't come. You wake up the next morning, there's lots of poop on your on your lawn. So yeah, thanks, Vusi.
Yeah, Bob.
Thank you, and that's Vusi Tenjekwayo, the international and renowned entrepreneur. I saw your advert on television, and also public speaker. Thanks for calling in. Let's wrap up the conversation then. Chris, we'll speak to you next week.
I'm hoping so. Thank you very much, Freddie, and thanks for the great questions.
Bye-bye.
Everyone. See you soon.